Hello everyone, you are all welcome to lecture number 1053, and today's topic is about the spectrum of light, or we can call it that is electromagnetic spectrum. Sometimes in instrumentation we also call it electromagnetic radiation. So what is light? First thing, in a very simple way, always the scientists, astronomers, physicists, chemists, all of us are very much interested about the sunlight, what we are receiving. We call it actually white light, but there is nothing like white, but just it is falling, so we call it generally white because other codes are detected like green, blue, red, and the color of each is determined by its different wavelength and frequencies. And if we are saying light, define light, scientifically, chemically speaking, light is the bundle of energy. It is in the form of photon, and according to de Broglie concept, light is wave. Sometimes it behaves as a wave, and sometimes it behaves as a photon. It can hit the substances. And for light, the first optical concept was given in Iraq, Basra. It was in 1100 or 965 BC by Ibn al-Haytham, and Ibn Hazan is in Western countries. His name is, he was a top-ranked astrologer, physicist of that time, and he did a lot about the light, but he failed to explain that light is having different spectrum of wavelength. Then Newton came, and actually Newton, he passed the light through prism. So when light was passed, it was a Newton who did it through nickel prism, and he found that there are different type of wavelengths, and that different type of wavelengths, they are in different color: blue color, yellow color, red color, and purple color. So, and then again he tried the red color, and he passed again the red color through the same prism. He was having impression that again there may be some splitting of red color into different one, but it never happened. So there he failed. So on that basis, according to Newton, because there are two fathers, the grandfather I can say, Ibn al-Haytham, the greatest physicist, astronomer from Iraq. That was the golden period of Iraq scientists, and after that then Newton. And then the concept of energy was given, and let me tell you first thing that if this one is given in terms of spectra, it goes like this. In that case, this area is shorter wavelength. It is called UV, ultraviolet, and here it is visible, and yellow, lot of other, and last it is called infrared. So it is the shortest ultraviolet light, that is your blue range. And this blue range is actually very short wavelength, high frequency, more energy. And when you are going to visible side, invisible, different spectrum are there. And after that, the longest wavelength, that we call it infrared. And infrared is having longer wavelength, and it is having less energy as compared to ultraviolet. So visible is coming in between this. If anything is within that, we are given only one range, and that is called visible range. If anything is falling under infra range, we cannot see. If anything is falling under blue range, we cannot see it. And the thing is that every substance, if any substance is there, that substance, its potential energy is there. It contains three type of energies. So once any electromagnetic wavelength or radiation is falling on that particular substance, once it is heated, falling means if any light is falling on any substance, it is providing heat. And once it is heated, first, if little amount of heat is provided, first that substance molecule will start vibrating, rotating. So first it is having three type of energy. One is called rotational, second one is called vibrational, and third one is called, that is electronic energy. That is electronic energy. So once, I'm not going to detail in deep inside the spectroscopic, because it is other branch. Here I am just taking very simply about the color code of the light and how they are going to impact our life and our lot of development, industries and everything. So I have given you the concept about the light is a type of energy, bundles of energy in the form of wave and frequency. That sunlight what we are getting, it is having 7 different colors, that is blue, red, yellow, violet, green, and once it is passed through nickel prism, we are getting this. Now I am going to focus on infrared, that is called IR. Infrared. This infrared is playing nowadays very, very important role in our daily life. It has lot of applications. And infrared means, I have already told you that it is having longer wavelength, low energy, and whatever it is falling on our earth, it is infrared. So lot of uses are there. For example, nowadays we have infrared camera, and that camera is very much applicable. Then infrared thermometer, body temperatures, and with the help of infrared night vision camera, it is going to detect your temperature. For example, with the help of infrared thermometer, once infrared is falling on our body, it is giving, for example, 2-3 temperatures. 38 degrees centigrade, somewhere it will give 27 degrees centigrade, somewhere it will give 28 degrees centigrade. What does it mean? It means your body is having, rather than that mercury thermometer, once you are putting inside mouth or anywhere you are touching, it will give only 38 or 37 degrees centigrade. That we will call it maybe 99 Fahrenheit degree. But with the help of infrared, so infrared will detect, because for example, if where there is head, our hair is there, it means your hair is protecting the emission of the radiation of energy from there. So there it will be low. So wherever there is hair, the temperature will be less as per infrared. Your eyebrow, the temperature of eyebrow will be less. And secondly, infrared, if polar bear is there or maybe ram, it cannot get the photo of that ram or polar bear, because it is shielded. Their body is densely with hair, and once it is densely with hair, it cannot, that radiation cannot come out. And unless there is interaction of the radiation of infrared and their body, it cannot detect the spectra. So infrared, even in the night, it can detect on the basis of temperature and it can locate. And then nowadays infrared thermometer, infrared camera, infrared cooker, infrared electrical appliances where you can cook the food because there are infrared bulbs. I mean, lot of new instruments are coming which are mainly based on infrared. Your bulbs, lot of bulbs are there which are infrared. With the help of infrared torch, you can locate so many things for your security reason. In medical, pharmaceutical industries, lot of infrared lamps are used. So it has lot of application. And not only that, some animals, they have different range. We have only one range, visible range. Within that range we can see. But some one which are having infra range, they can locate in the night. That's why snake is having infrared, IR range in their inside what the eye is there. So with that infra range, that is wavelength, infrared that is called wavelength, longer wavelength, in the night, any light or any small substance which is moving, it will give fluorescent light. Once it is falling, and immediately they can catch to snake and so many other animals, reptiles. They don't have this vision visible. They have infrared. So like that. So in that case, it is having multiple applications. So as I have already told you that the color spectrum of light is very, very important. Nowadays, it has lot of application, and I have given about its discovery. So number one, that is Ibn al-Haytham. He was the greatest physicist, astronomer, and he was in Basra. That was in the year 1011 to 1021. That was in Iraq. And he is known as the father of optics and the light. And also, he is the first man who gave the concept of camera. So the discovery of camera also goes to Ibn al-Haytham, and in Western countries, his name is there. And his name is mentioned there, al-Hazan. So al-Hazan is in Greek, English term, and his Arabic name is Ibn al-Haytham. If anybody who is interested in his discovery, because at that time, that was in 1000, Abul Sina, al-Haytham, al-Razi, there are a lot of discoveries done by Muslim scholars, and it was in Iraq. Iraq was the center of scientific discovery. That's why everything is al. Al-Jabra was discovered there. Al-Kali, Al-Kohal is all discovered in Arabic countries. So all was in Arabic language. Then it was transferred to Roman, Italians, and then Greeks, and they changed with their term. So that is about the light. And then what happened? Ibn al-Haytham, he failed actually. He just mentioned that a light can go, can travel, and the camera, reflection, everything was discovered by him. But he failed to tell, and according to his concept, that light is having only one wavelength, one frequency. But he failed to understand that it is having color spectrum. And the color spectrum was discovered by our another very, very renowned scientist. His name was Isaac Newton. It was in 1642 to 1726. During this period he worked. And modern understanding of light and color spectrum was given by Isaac Newton in that year. And in the year 1672, his research paper was published on refraction of light by prism. He passed the light through a nickel prism, and it was split into different color, that was red color, orange color, yellow color, green color, blue color, and violet color. Then only they started the concept of color spectrum of light, and again the electromagnetic spectrum. Electromagnetic radiation, electro means it has energy. That's why it is called magnetic power. That's why it is called electromagnetic spectrum. The word electromagnetic came means it has magnetic power. It has energy. That's why it is also called electromagnetic spectrum. Then number 3, IR radiation is invisible to human eye. And I have already given a lot of explanation that human eye is having only one range, that is called visible range. If it is in the range of infrared or ultraviolet, we cannot see. And the value of the wavelength of IR lies between the range of 740 nanometer, that is equal to 4 into 10 to the power 5 nm, and the frequency band is 300 gigahertz, and it is between UV and visible range. Now the applications. There are a lot of applications now. Lot of applications in every sphere of light. And infrared light is playing big role in industries, in household, in detection, in military purpose. Lot of things are there. So that is applications means first is that is remote control. Whatever remote we are using in our houses, for any purpose remote, is all because of infrared wave, infrared frequency, and that is going striking and giving the signal. That is what is known as remote control. It is used there. Then thermal imaging. Thermal imaging, I have already told you that your image is coming out of heat. That's why I told you that once it is focused on our face body will give different temperature, different IR thermal heat indication. Somewhere it may be 35, somewhere it may be 38 or 37, somewhere it may be 29, somewhere it will be 27. Because where it is protected, your body, what it is radiation is reflecting, and somewhere where the reflection of the heat, that is thermal form, like here, like eyebrow, it will not detect because it is less. So that's why different temperatures are there. And once it's a total shielding, is protected, like you cannot get IR image of polar bear because it is having so much thick hair on the body or some realms, because radiation is not possible. It's all shielded, it's all protected. So that is for that purpose it is used, imaging. And in the night also, with that reflection, you can locate, because in the night, how IR camera is using, we are using, I have given the camera also. Anyway, this imaging comes under thermal imaging, and then IR camera also. I can say IR camera. IR camera, how it is working in the night. That actually if any object is there in the night, if you want to get the photo, in the night even there are in traces some fraction of wavelength of visible rays is also there, and wherever little visible range is there, and it will go and interact with that infrared, and it will provide the image even in the night. That is the role of IR camera, that you can get the image in the night also, and also that is imaging also. IR cooker. Now such type of cookers are coming where IR range heating procedure is introduced, and with that technologies they are putting heat lamps, and those heat lamps they are providing enough heat for cooking purpose. That is called IR cooker. Electric heater. In electric heater also nowadays IR electric heaters are produced, and it has three components. One where the IR bulbs are there, they are providing the enough heat, and that heat should be circulated. So the fan is also attached, so the uniform distribution of heat is there. So in this way, IR heater is also there. Then IR in astronomy, in the space, the IR is widely used to understand the cosmic factor and some weather condition because of getting the IR imaging. So that is also nowadays it is used a lot. Then historic art restoration. Historic art restoration means where if suppose any painting is there, which may be 500, 600 year old, and some damage is there. So with that damage, a reflection of IR interaction with that color wave, it will give the information that how it was damaged, when it was damaged, and the status of the whole art. So it will give the historical background of that art. So these are all very, very important applications. I did not go in detail because the lecture will be very lengthy. So those who are interested nowadays, all these informations, especially the application of the IR in different places, how it is used. Lot of industrial applications are there with IR lamp. There are a lot of IR lamps are also produced here. I have given about the IR lamps in industries, in pharmaceutical companies, and with that they are checking and doing the work. And one more, let me add, IR is also used as at 9 and 10 IR spectra for structure determination. This IR, that is called IR spectra. So this infrared is used to determine the structure, and I have already told you in the beginning, the substances they contain three types of energies: rotational energy, lowest, vibrational energy, and then electronic energy. So if that electromagnetic wave or radiation is focused to that compound, it will start vibrating, and where the functional groups are there, with the help of staging frequency, that is reciprocal centimeter staging frequency of IR, will give the spectra that particular functional group there is specific range of spectra. On that basis, we can locate the functional group in all the organic compounds. So nowadays, IR spectroscopy is there to understand and to determine the structure of unknown and known compounds. So with this, I will stop. And this spectral studies, my at least 10 lectures are there where I have discussed about NMR, IR, UV, mass spectroscopy, and how they are used in modern age for different purposes. With this, I will stop. Thank you very much for watching the lecture.